I'm going to show you a few demonstrations, and those demonstrations seem simple, but they're not as simple as you may think, and that's the reason why I do them. I give Skype lectures to high schools all over the world. I do that from this location with this instrument. Ideal is that the kids are between 14 and 17 years. If they have already bachelor's degrees in physics, this is not going to be very surprising to them, although many may have forgotten their physics. So I start with kids 14 years old, and I say, look, I have here a plank. The plank is nicely brushed, is smooth everywhere, but not exactly the same smoothness, but very close. And I have here an instrument that tells me what the angle is of this plank. You have to take my word for it, it's 7.6 degrees. So, if I put this object on here, this is plastic, it's nicely smooth, then it will stay there. You would say, why does it stay there? Because why doesn't it slide down? Well, you know the answer, all of you, because it's the friction that holds it in place. But if I make the angle larger, there comes a time that the friction is no longer capable to compete with gravity and it starts to slide. Let's see at what angle that happens. So I read, and you have to take my word for it. I go very slowly. 10 degrees, 13 degrees, 15 degrees, 16, 17 degrees. Okay, you're not impressed, right? Now I have a question for you. Suppose I put in here $600 grams. And I'm going to do the experiment again. 600 grams. So the weight that I have added is probably 60 times the weight of that little plastic box. If now I raise it again, do you think that it will start sliding earlier than the 16, 17 degrees? Or that it will be much later? Or that it makes no difference? Those are the three options.
You probably think it would be earlier, do you think, with the actual
You think
weight?
earlier.
I think about 12.
You think about what?
12.
Lower.
Lower.
It will
yeah.
go earlier.
I think it'd be about the same.
Okay, anyone else? 10, 12, 14, 15. It's in 1 degree the same.
Similar then.
And that, of course, is what I teach students in class. Now, the reason why it isn't exactly the same within half a degree is because the plank is not everywhere the same smoothness, so it depends on where I put it. If I did the same experiment 3 times in a row, it would differ by 1 degree. But the remarkable thing is that with this incredible weight in here, makes no difference. Now I have an easy one for you. I have here a stapler, and the stapler has a rubber at the bottom. What now do you think? Will it start sliding earlier or will it start sliding later?
I suppose it's stickier, so maybe you think is there more friction? Is it so maybe later?
Yeah, maybe later.
I think so
Yeah.
too. I mean, clearly rubber is much more friction, and so there we go. 13, 15, 16, 18, 19, 20, 21, 22, 22. So it's clear that it is more than 16. All right, so much for the friction. Now let's go to something entirely different. I have here a brass solid cylinder. And here I have an aluminum one with the same dimension, the same radius and the same length. Now this one is at least 5 times heavier than this one, maybe 4 times. And I'm going to do a race between them. I don't need this anymore, so I can remove that. Angle is not important. And now the question is, which one do you think will win the race? Which one will reach the end first? The heavy
silver
one? Or the light one? Or maybe they arrive at the same time?
What do you think, Fee?
I think the silver one. The
You think
heavier
what?
one. The heavier one.
The heavier one will win, right?
Yeah.
That seems reasonable, because if you're heavy, you go a little faster, right? Okay, I'll give you the aluminum one on your side. Ready for that? 3, 2, 1, 0. No difference.
Dead heat.
No difference.
Why is that?
So we know that if the cylinders have the same length, the same radius, that weight is unimportant. Could be anything. This could be 10 times heavier. Okay. Now I will have here aluminum, and I have another aluminum which is shorter. They have the same radius, but now this one is shorter. Which one do you think will now win?
I suppose the surface area, the longer one, is that larger? So would that have more friction? So would that be slower?
You think this one will lose the race?
The larger one will lose the race.
Will lose the race. Very good. Let's take a look. 3, 2, 1, 0. No difference. So now I have shown first that the weight is unimportant. I have now also shown that the length doesn't matter. Now comes the question, I have here brass. We already agreed that the material doesn't matter, right? Whatever the material is, that makes no difference. But now the radius is very, very small. So they're both solid. The fact that they have different materials, it's no problem. We have already demonstrated that doesn't matter. They have different lengths. We have already demonstrated that that doesn't matter. But now comes the issue, would it make a difference if the radius is so different as they are? What do you think now?
What do you think?
You think the smaller radius will win or the larger radius
I think the larger radius.
will win?
Yeah.
Well, you have a very good intuition. You ready?
Yes.
3, 2, 1, 0. No difference. In other words, I have now shown you something quite remarkable, which is not at all intuitive. As long as a cylinder is solid, it makes no difference, number 1, what the material is that it is made of, number 2, what its length is, number 3, what its diameter is. They will all roll down in the same time. Now I have a last question for you. This is aluminum solid, and this is aluminum hollow. Now we're going to do a race with these two. Which one do you think will win the race?
I think the solid ones.
The solid one will win the race.
Yeah.
Do all of you think that?
I suppose because the weight, we've already shown the weight doesn't really matter. So it's whether there's any airflow comes into it, maybe because it's hollow, could that affect it?
Well, what is your vote?
I would say the solid, intuition.
The solid one will win.
Yeah.
You will think? Same time.
I think
So we have 3 people for
same time, I think.
this one will win, and we have you also the same time?
Same time.
2 people same time, 2 ones, this one will win. 3, 2, 1, 0. The hollow one will always lose. Independent of its weight, independent of its diameter, independent of its length, the hollow one will always lose. So then I show the kids, I tell the kids I have here 2 cylinders, and I'm not telling them which one is hollow, but one of them is hollow, but you can't tell. But now they understand that the hollow one goes slower. It will be very easy for them to determine which one is the hollow one. 3, 2, 1, 0. Hollow one always loses. I will show you last but not least, a larger difference than what I have here you cannot even imagine. This one is enormously heavy, enormously light. This one is way longer, enormously small radius compared to this one. Even these two, since they are both solid, should arrive at the same time. Three, 2, 1, 0.
Same time again. So is there a simple way of explaining why?
No, it's not simple.
No.
No, you need calculus even. No, it's not a simple way. No. But what I can tell you, I can give you maybe a feeling for it. If you take these 2 cylinders, then the outer cylinder, the outer circumference, has the highest speed, of course. The inner one has a much lower speed. In other words, if you look at it from an energy point of view, have you ever heard of the word kinetic energy? Okay, so if you think of this as a series of shells, but they're all together solid, then most of the kinetic energy per weight is on the outside and not on the inside. Right? Because the speed is higher. And so if I make slices which all have the same mass, then the ones with the highest speed have the highest energy. Well, kinetic energy is 1/2 mv squared. Yeah? Now here, all the weight is at the outer portion. Therefore, all the kinetic energy is sitting in here, in the part which is the highest. And therefore, it takes more time to go down, because it's not so fortunate that it has mass here which takes very little energy. So this one demands way more energy per weight than this one. And therefore, it is purely a matter of geometry. The hollow one will always lose.